I mean, I
Okay.
don't really. It's kind of like foggy too, so I just they have it
Yeah,
like it old, so I just think like, oh, I have to use it.
well, that
I
makes
mean,
sense. Like, okay, they put that for a reason. And reading 8 makes sense too. Find the z-score for the sample mean of the capacity of 20. So you're looking for the mean of all the tanks versus one. Okay,
mhm.
it's coming back. Hopefully it does the same for the test. Okay, so then I didn't divide it. So it'd be 12 divided by 50?
Square root of 50.
Square root of 50. Okay. So 50. 12 divided by that. Okay, and then we do -4. Man, I thought I had it so I was like, I'm totally on the right thing because it was just -4 divided by 12. So I was like, oh, simple. They just want us to do it in our head. Great. Okay, so now I got -2.3569.
Yeah, I think that's right.
Okay. So then the probability I get is 2.3569. So I got a huge probability. I got 99.08.
I got
Is that
a
what you
point
got?
1. What did you get again?
0.91. I got 0.9901.
99.
Oh wait, is it?
Oh, did you do greater than?
Did you get a negative z-score? Yeah, I did greater than.
Yeah, I got negative.
Okay, what was the z-score you got?
Oh, negative 2.357.
Okay, that's what I got. And then I highlighted the middle and the right tail. Is that what you highlighted?
Yeah. Let me punch in mine again to see.
Oh, you know what? Oh my gosh, so dumb. You got 991.
Yeah. What did you get?
Oh my gosh, I just had it. Yeah, I got the same thing. I just um I, yeah, I just didn't round mine, so I
Oh
didn't
yeah,
get the
yeah.
same
Point
thing. So
nine.
0.991.
Yeah.
Okay, good. I was like, no, I got 0.8. How did we get off? Oh, rounding.
991.
Okay, so 0.991. Great. That's a huge difference. I'm glad we went over that. Which one of the following best describes? So I think you told me this last time, and the significance level of hypothesis is the probability of a type 1 error. Is that right?
Uh,
No?
well,
What
hmm.
did you think it was?
I put D, but I mean I can see it being A.
D was my first gut feeling, but I remember us talking about this question before. So I just went to, and I'm not saying we have to put this in here. I would rather figure out what's right. But I just went to, in the online textbook, I went to the index. I'm trying to remember. I just typed up on the online textbook, I typed in level of significance. And it, take a second. And it popped out the index. And on the index, the level of significance states that it is, let me see, a number that is used to determine if the p-value is small enough to reject the null. It also has a probability of committing a type 1 error. But D was also my first gut feeling.
Yeah. Let me see what's. Oh, which one
Oh,
falls describes the notion of the significance level of a hypothesis? Oh yeah. I think it'd be a type 1 error, wouldn't it? Like you're saying,
yeah.
because
I
a
remember
type
us having the same conversation. Go ahead.
type 1 error is when you reject the null when it's true. I think. Let me look at.
Yeah, I think so.
Oh yeah. Whenever we reject a true null hypothesis, we say that a type 1 error was committed. Yeah. So if it's 5%, well, if it's 0.05, then it'd be a 5% chance of an error, type 1 error. Yeah, I guess it'd be A.
And I think I think last time we were in like the opposite position, I was saying D and you were saying A, and I was like, really? And then it was. I remember being like, oh, I think 10. I think D is the probability of is the p-value. I think that's the definition for the p-value.
Yeah.
So anyway, that's all I have to say there.
Number 11. I said B or C.
And I also said E. Let me see, what does E say again?
You said D?
E. I said B, C, and E.
Oh, you said B?
Yeah, let me reread it though. I'm not sure. Okay. We're 95% confident that the true mean height. Oh. Yeah, it's not B. So I had that we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
Yeah.
And then I also have C, which is approximately 95% of all 95% confident intervals could be computed from the population. Is that right?
I remember. Well, it didn't say approximately last month, but there was that.
I always remember that like 95% 95% confidence intervals or something along those lines, right?
Yeah.
And then I also said, and this could be wrong, but I said the very last one, 95% of the heights of female adults in our sample are in this in our confidence. Is that totally off? I think that is wrong. I'm thinking more of like just the applet, like when you do a z-score of 2, you know that 95% of them are going to be in there. But that's the z-scores. That's not confidence intervals. So it's not E, I don't think. I just talked myself out of it. Does that make sense? So, because I was just thinking of the bell curve and how when you mark it at the z-score of 2, there's 95% underneath the bell curve.
Mm-hmm.
That's totally different. So, okay, so B and C.
Okay.
Does that sound okay?
Yeah.
Okay. Okay, so 12. Marine biologists have been studying the effects of adaptation. Also, they data follows the normal distribution of the populations. Did you say A?
Yeah, I said A, but then I thought it could also be B as well.
B.
Yeah, because I think it had it needs to be normal, and then also you need to at least have 5 samples.
Yeah. Yeah, I totally see that point. I think typically for like a large sample size, it's considered 30 if it's not normal. And so I think, I mean, I guess, well, the logic you're using makes sense. That needs to be over 5. But if you look at it, you first prove that it was normal, but then the 6 was okay. So I think it's A.
You think it's what?
I think it's A because it's more
Oh.
important that it's normal than the data size is large.
Okay.
Does that make sense? Because even when you explain it to me right now, you said, well, we know it's normal, so 16 is enough. But it's not normal because 16 is large. Does that make sense?
Yeah.
But that's a good point. An investor with a stock portfolio worth several $100,000 to a broker. Man, I know we've done all of these questions before. Ah.
What p-value did you get for this?
I hadn't done this one yet. I'm so sorry. S&P, well, I've done it at past quiz, but S&P has known population mean return. Okay. So, what? Sorry, I kind of skimmed over it fast and it didn't really make sense to me. So what are we supposed to do?
So you open up a data file, rates of return.
Oh, and then do you get a mean?
And then you do a hypothesis test on it, data, to see if it's different. Well, the words that what they want you to do is, it says, the average of the standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial difference.
Okay. So significant. And can we just do this test in Excel, or should I be opening SPSS?
Let's see. I think for this I did it independent. No, I did one sample t-test.
Okay, so do an SPSS. Can I do, because my computer's going to take forever to open up SPSS, okay, I don't know how you feel about this. Just tell me, if I pull up and let you know what mean I get, we can just compare it with your mean, and then if it's the same thing, you know what I mean? See what you got. Is that okay?
Oh, I just have the t-score.
Oh, you have
written down.
Okay, okay, I'll start, sorry, my computer's been slow. I'll start opening up SPSS and let's move on to another problem, and then I'll come back and once my computer downloads it all. Is that okay?
Yeah.
That way we can just do this long quiz a little faster. That's funny, I stopped right before you need to start downloading all these things. I'm like, oh, great, whew, made it that far. Okay, so that's downloading. Going back to the next question. Okay, a financial economist, I gotta mark 13 that we need to do it. Financial economist is studying married couples and which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. So this is dependent sampling, right?
Yeah.
And so D?
Yeah, I picked D.
Okay, perfect. Pressures of supply and demand act directly on prices of airline tickets. As the seats available on the airplane begin to fill, the prices change. If a seat not well, they discount the tickets, yada, yada, yada. So they compare 90 days to 14 days. Oh, I remember this. For her study, she compared the prices of one-way flights from London airport to various destinations in Europe. Using this blah, 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 she compared them. Okay, I remember this one. I will download it really quick. Direct flight cost, right?
Yeah. Now, I thought this one was paired samples. Is that what you thought as well?
You thought it was what?
Uh, Paired samples.
Number 15 or 14?
Number 15.
This one about flights. Yeah, we compare 90. We compare the same flight, so it's paired samples, isn't it?
That's what I thought.
Okay. Yeah, I think so. I remember doing it last time, and I think we did a paired sample test too. Because I remember us having to figure out, do we fill in the zeros? What do we do? And ultimately, it just didn't include them, I think. Or, I can't remember. So, it's called direct flight costs. Okay. Oh, poor Brian has to do this all by himself.
Yeah.
That's a lot of work. Poor guy. Okay, so paired. Isn't there something about running a paired test where you have to do the orders of the days? Like, never mind, I don't know. Like, it depends what you put in variable 1 and variable 2.
I think it only kind of changes it flips the negatives if you have them in the confidence interval. I think I can remember.
I think it's the last minus the first, right?
Yeah, that's just kind of like what they told us.
And are we doing this at the 95% confidence level?
Uh, I probably wouldn't worry about it because you didn't ask for it.
Oh, got it. Good. Okay, cool. So, what does the question ask for? What is the p-value for this test? Isn't it sig that we look for? I got 000. Is that what you got?
Uh, I think that's the top.
Oh,
Uh,
yeah, I'm like the paired samples test. Okay, how about this one? Did you get 0.096?
yeah, 0.096.
Okay, I looked at the wrong significance one. Okay, 0.096. Okay, based on these results, do you subtract or amplify? So,
Uh,
I said no because the p-value is greater than the level of significance.
yeah. So you can't see.
Okay, real estate company wants to evaluate 2 of their home appraisals for consistency. I remember this. Company takes a random sample of 10 homes in different areas around the city and then tell me which of each has been. I don't remember very well, but I want to say B.
Let's see. I'm still reading it. So you can created an estimate of the whole value of CPSUs for each home. The company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ of differences. See that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? Like, so does it form a normal distribution?
So it's essentially saying, what do you need to make a confidence interval with paired testing?
Well, it just needs to be at least, you need at least 5 samples, I think, right? For a confidence interval.
I think so. Let me see. Yeah, I think so. Well, isn't there something about variance too? Like it can't be 2 times bigger than the other. I'll look up the paired testing in the book, okay?
I almost forgot about that.
I know they have that form in them. I don't know. I think we might have a group meeting for the next time, but I think if we had enough time to just go over our notes and like make sure we have all the random facts for each type of test, would be helpful for me. Okay, so paired data. And let's see, confidence intervals. Okay. So I had the requirements of, okay, here goes. For the requirements of creating a confidence interval for the difference of means for a paired test are the same as requirements for the hypothesis test. We assume that it is a random sample, a simple random sample, and that the mean of the differences is normally distributed. So I don't know if that helps us much.
What lesson is that?
Oh.
Is it just lesson, is it the paired samples lesson?
Yeah, inference for 2 means paired data. Lesson 12. And then, actually, so I just went straight to the confidence. Go to, or if you go to 3.2 and then right above have the QQ plot, that's technically statistic.
3.2?
Yeah, or just above. So you go to 3.2 and then scroll up a little bit, you're going to see QQ plot.
Okay, yeah.
So these are the requirements for doing the ones for the t-test. It looks like they ran the QQ test just to see if it was still normal. And then when you go down to the confidence interval, it says that at the very bottom it says the requirements are met, it's normally distributed. I don't know, so I don't know if you need to do the QQ test. Like they just, okay, so they say in the hypothesis that you just need to know that's normally distributed, so they do QQ test. Or QQ plot, and then down here in the confidence interval they say you need to do what you did in the other hypothesis test, but it doesn't mention specifically QQ plot.
Okay. Yeah, I see here now that, yeah, it's simple random sample and, you know, it's normally distributed, so I think it meets those requirements, doesn't it?
Okay, now I've lost what the question was even asking us. So the distribution means difference is normal because the data have been determined to be normal. Oh yeah, because it's not even asking for a large sample size; it just has to be normal. Okay. Yes.
So
Also, oh, go ahead. So yeah, I said B. Okay, then I also ran the test for number 13, and let me see. I don't know if I just did a one sample t-test, and let's see. I got, sorry, so 13, the p-value I got was 0.257.
for the p-value,
Yeah.
okay, I got 0.039.
What did you get?
0.039.
Okay, so I just took the data and I just did one sample t-test, I think. I don't know if that's right.
Let me see how I
Oh,
can
wait. Okay, go ahead. And then I think I know what I may have done wrong.
see, rate of return, isn't it?
I think I have to put in the test value. Okay, I didn't put in the test value.
Oh, you left it a 0?
Yeah, I left it at 0.
Oh.
So it is 0.95. Oh God, my second. Is that right? 0.95, I think.
You got 0.95?
No,
Oh,
that's the.
yeah,
Is that
that is the mean return. Yeah, 0.95.
Okay, so now I got 0.039. Is that what you got?
Yeah.
Okay. Man, there's so many little things to remember. Okay, perfect. Okay, so now we're going back down to 18. Now suppose the company of the previous items want to use a hypothesis test to determine whether the estimates given by the two appraisers are different. Which of the following would be the most appropriate for such test and why? So essentially, what is the null and the alternative for paired testing?
Yeah. So that would be, I think, A. Oh, wait a minute.
I thought A, but when I was just looking at those lessons, they had 0.
After this company, the previous item wants to use a hypothesis test to determine whether the estimates given by the two appraisers are different. Different? Which of the following would be the appropriate pair of hypotheses such a test?
Okay,
So,
I think it's D.
you think it's D?
D.
B?
Cause I was reading the inference or the lesson, and it says that the difference, right? Like the mean is the mean of the differences. So like 1 minus the other is one data point. So like you take the husband's minus the wife's salary, and that difference is the data point that you work with. So you're really getting a mean of the differences between the 2 points. And so it's either there is no difference between the 2 points or there is a difference between the 2 points. So the no difference between the 2 data points that are connected would be 0 because like the same, there's no change. For example, the cost of the flights are the same 90 days and 14 days. Or there is a difference, so it's not 0.
Uh-huh. So you're saying number C?
So I think C, yeah. Because they just want to know if it's different. So the null would be that there is no difference between their 2 data points. And then the alternative would be it's either negative or positive, but there is a difference.
I think that's the test we did, right?
What?
I think that's the test we did, right?
Yeah, I think so too. I think we did.
The test they did do was they.
I think you want to share down a bit. Maybe it's like 8? Oh, 9? Okay. Sorry, Colby, what did you say?
Isn't that the test they did?
Sorry, say it one more time.
Isn't that the test they did? What's the difference?
Yeah, we did the test right, I think. I'm just saying for when we quote the null, like for 18, I think how you state it is C.
Huh.
Does that make sense at all?
On this, I don't know. I think the terminology they might be using is like a paired sample. I'm not sure if now they want to take the mean. Like if they're separating the data, the 10 data points, and they're going to take the mean of one, the mean of the other, and they're going to like.
Compare them? No, so how they do the paired is they take, because they're connected to each other, so each instance with one, you'll have an instance with another. So really to compare them to see if there is a effect on one on the other. The difference, so if I take 1 minus 2, or like data point 1 minus data point 2, there's going to be a difference. And then once they do the differences for each of those tests, they use that data to run a one sample t-test. Does that make sense? No?
Let me read it again.
What question are you thinking about? Are you thinking about the last one?
Yeah, I think it is C, like you're saying. Yeah.
Okay. Oh, yeah. I think the mu1 equals mu2, I think that's for independent testing.
Yeah, for some reason I thought like they already did. I think what was getting me confused was they said not suppose, so I just thought like, oh, they already did that. Now I can do this.
Oh, okay. So yeah, they're trying to make us think of another situation. Okay, that makes sense. Okay, give me 1 second. I'm just gonna say goodnight to my husband really quick, so he doesn't forget one thing. Right back. Okay, sorry, Colby. I just had to make sure I got that done. Okay. So 19. Suppose you create a 95% confidence interval for mean and get this number. You're told to report by saying we're 95% confident that the true mean is between this and this. What does that exactly mean?
95% of all 95% confidence intervals actually contain the true mean.
Yeah. It's not D, is it?
95% of the sample means, I don't know.
You know what? I think this could be catching us just on the wording, because when I read the problem, I think they're just talking about one mean. 95% confidence interval for a mean and get this much. You've been told to report this by saying we're 95% confident that the true mean is between this. I think it's B because it's
it
just
could be
one mean.
in the question they use the word true mean, and then in the answer they use sample mean. Sample
Yeah,
mean.
I think that it's B because I think D it's like you were pointing out to me before. Sample mean versus one mean. Does that make sense? So are you saying B?
Uh, I don't know.
I don't know. I really do think because it's only talking about. So suppose you create a 95% confidence interval for a mean and get this. You've been told to report this by saying we are 95% confident that the true mean is between these two. What does that mean? So I think if it was a sample mean, it would say we're 95% create a 95% confidence interval for a sample mean, the sample means, and you get this. You've been told to say. I think you would word it. I think this is a one sample t-test versus multiple t-samples.
Let me look it up in the book real quick.
Yeah. Let's see.
Interpretation of confidence. Confidence interval for the true mean. When we interpret this confidence interval, we say we are 95% confident the true mean is between. The word confident implies that we repeat this process many times. 5% confident we get contain the true mean. It does not imply anything about whether or not one specific person will meet true mean. Do not say it is like probability of chance of a true mean. Sorry, I'm trying to like.
No, I'm. You're fine. I was going up.
I have a problem with that wording, like, sample means. So I'm trying to look around and see if I can kind of like make sense of it.
Yeah, no, take your time. I was looking up farther to see if we had something similar to it before. You're fine.
Mm-hmm. Considering that. Does not imply anything about whether or not one specific confidence interval true mean. 95% of the sample mean. True. I'm not quite sure.
What I was looking at was, and I'm not positive. What I was looking at was up farther. For explaining to me standard deviation divided by the square root of n. And when I was looking at, to me, it made sense. Let's see, 6. If you look at 6, it's just asking you to do like the true mean, or well, this gives you the true mean, but it's just that simple one where you try to. Okay, how do I make that simple? Like instead of looking for sample means, you just look for the one. And I think, whereas like right after that, we had to figure out the sample means. And I think for this one, they're just doing it for, like, it's a one sample t-test, because you don't know mu, but you do know the standard deviation, right? Well, I guess we would if we were doing the confidence interval. So I think, anyway, I really think it's B, but, and I think they're just trying to mess us up by saying sample means. Well,
I guess I'm kind of wary of that one, just because like I don't think we've ever ordered it like sample means.
You don't. Sorry, say it again. Let me put the speaker on it because it's really quiet. Hold on.
That word is sample means.
Okay, pause just 1 second. Let me switch this off. Okay, what did you say?
I kind of think it might be B, just because like in this it seems like it's talking more about the sample means than the actual intervals.
That's what I think too. It's just something about G. I'm like, not sold on it. Although it's pretty close.
Yeah.
So, yeah, let's go with B.
Okay.
Okay, so now we need to do P hat. Okay, so the P hat is in the lesson 16.
Mhm.
Oh, I just picked memory instead of the actual.
I think all you need to find is N, right? Number 20.
Yeah, I just can't remember.
So I think one of the conditions it's like N times P is greater than or equal to 10.
Oh, and then you just go off that, so you do 10 equals.
Yeah, then you just do like N is greater than or equal to 10 times 5 divided by 4, 50 divided by 4. I think it's like 12. 0.5.
Okay, so 4 divided by 5 is 80. Okay, so n times 0.2 equals 10. Did you get 50?
I got as n 12.5.
Okay, so 10 divided by 0.8. Okay, so I think, so what you did was n times p, but if you do, oh, that actually might make sense. No, because then the other thing you have to qualify is n times 1 minus p, right?
Mhm.
And n times 1 minus p, 1 minus 0.8 is going to be 0.2, so that's a lot smaller. So if you did 12 times 0.2, you're going to get, point or 2.5, so that wouldn't qualify it.
Mhm.
So I think you just have to do exactly what you just did, but instead of 0.8, solve for 0.2. Did that explanation make any sense? I'm so sorry.
Yeah, I did. Yeah, use the other one, it gives you a really large number.
Yeah.
I don't know. I can't remember if it really mattered which one, but I don't care which one we use. So
Well, no, I think you're right. I think you have to do, well, you have to do n times p is greater or less than 10, but then you also have to do n times 1 minus p is greater or less than 10, and so both of them have to be satisfied. So, we have to check both, which is good that we did. But I can't, for doing n times 1 minus p, if I put in 12.5 times 0.2, you're going to get way under 10.
mhm.
So we just have to figure out with that equation. Does that make sense? Or did that answer your question all, or did I just repeat exactly the same thing and you?
Let's see. Oh, these gonna hold up. Look at it. Large is
Yeah, it's
like
on. So it's less than 16, and I went under point. No. 3.2 or 3.2.
okay, yeah. Oh, yeah, we had a problem here. And say, oh, how many samples should you have to be satisfied? Oh, sample size calculations.
Oh, where's that?
That is. Oh, yeah, that's the lesson 17, but I think it
Is it
requires.
for a different?
Yeah, it requires to have a margin of error.
Oh, okay. Probably not for p-hat, huh?
Hmm. What is the smallest value of n that satisfies the requirements?
What does it say to do?
So all you have to do, you have to find the smallest value of n that satisfies the requirements. So you have the two requirements, right? You have n times 1 minus p, right? It's greater than or equal to 10, I think.
Uh-huh.
You have n times p is
Uh-huh.
greater than or equal to 10. So you have to find the smallest value. That's what they're asking.
So,
Smallest.
yeah. That makes, yeah.
So
then,
it's like there isn't like one answer, but they just want the smallest for it to be
the
satisfied.
smallest value of that possible. That makes sense. So then we'll be like, all we need to do then is just figure it out. Well, then that's exactly what we did, right?
Yeah, that's what we did. Okay, so from one I got 12.5, and the other one I think you get like 50. Okay.
Yeah, I got 50 and 12.5, yeah.
Okay.
So then we would need to do, but we would have to do 50, right?
I don't know if it's the smallest value.
Well, because so for example, the 12.5, so that was in, and we ran it by. So if we took 12.5 and we went to go check the requirements, okay, let me show you an example. So if we put, okay, so.
Okay, I think I get what you're saying now. Yeah.
Does that make sense? I want to go draw a little picture about it. But, so, I think you get it, Art, now. But, so I just said, like, can you even see my notes? This is my good effort. So if you put 12.5 in the first one, it would work, but it wouldn't work if you put it in here. And then we would need to. Okay, sorry. I just drew my picture.
Satisfies both requirements. So, yeah. So,
okay. Oh my gosh, I thought I just closed my quiz and I almost had a panic. Whew. So I was trying to over. I was like, no! Okay, so 50. And then your little brother has a career batting average of 2.233. You want to determine the probability he will have a batting average of over 2.5 next season when he'll be up to bat 40 times. What are the conditions met so the same proportion will be approximately normal? I don't remember. Okay, so going on to the online text again.
So the last question applies to this question.
Is that the only requirement?
Yeah. Like if you go back to 3.2.1, how large is large enough? Talks about we can apply it to central limit theorem to a sample proportion and conclude that p hat follows a normal distribution.
Okay, so it has to be over 50. Or not over 50, have to figure it out. Okay, so 40 times. So do you do it times p hat, or do you do it times 0.233?
I think it's 233, right?
Yeah, because that's the proportion, the population one.
Yeah.
233 times 40. Okay, so 0.233. Okay, so I have that it isn't met because 0.233 times 40 is under 10.
Okay. I'm still calculating.
That's totally fine. Sorry. There we go.
Oh no. So, yeah, I have the else too. That doesn't meet one of the requirements.
Okay.
So number D, no, 40 times 0.233 is less than 10, right?
Yeah, I agree. Yeah. Okay, 22. A geneticist takes a random sample of 146 cells from the testes of a dog to determine the proportion which contain the chromosomes for development of the cell. Assume the unknown true proportion of dog gametes that contain the male chromosome is 0.46 or 0.66. Uses information for the next question. The geneticist conducts her survey and calculates p hat to be 0.512, which will find most correct interpretation of this statistic. Okay. Chromosomes for development each of male.
There is a 51.2% chance that anyone cell will have a male chromosome.
I think it's the last one.
So, but that wasn't what he was sampling, right? He was sampling. He took a random sample of 140 gamete sex cells from determining the proportion which contain the chromosomes. Oh, okay, so yeah, we developed 51.2% of the gametes in the sample have a male chromosome. Yeah, probably would be
The
that
hard
one.
one. I can read it like, what is
Yeah, I think it's the.
Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar, obsessive compulsive delirium, Alzheimer's. In the U.S., 45% of adults over 65 suffer from one or more of these conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 suffer from one or more of these conditions under their consideration. Okay, so we just figure out 320 divided by 750 for our p, right? And then we do that minus the population proportion divided by something.
Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffered from one or more of the conditions under consideration. Yeah, if I already do it, D-score. %. Oh.
Okay, so I went back and looked at the equation. I think you do so that the proportion that we find minus 0.45, so kind of like, you know, x minus mu, and then you divide it by the standard deviation, and for less than 16, the standard deviation is p times 1 minus p divided by n, the square root of all of that.
Yeah.
It's a, okay, and that's what we put on the bottom of the denominator for this problem.
Yeah.
Thank you. Sorry. P. How many P? Okay. It's a lot of calculation.
Oh yeah, these are the problems where you have to be careful of the standard deviation. Remember that now.
Oh yeah, like you can't round at all.
Well, you have to take it out to like 6 decimal places, or if you get.
Okay, I remember that now. Did you solve for the standard deviation already?
Yeah.
What did you get just for the standard deviation?
0.018165902.
Okay, I got the same thing. I just want to do that before we kept calculating, so we knew we were on the same page.
Let's see. So. 7, 4, 7 minus 0.45. That's. I feel like we did this problem before.
You got what?
So I feel like we did this problem before.
Me too, and I feel like I got a really weird answer this time. I'm gonna try it again. 0.422 or 266 minus
6, 5, 9, 0, 2.
Oh, that's better.
0.266. So I think it's really that less than. So
What did you get for your test statistic?
negative 1.266.
Okay, I got negative 1.288.
Oh.
But I carried mine out like 10 extra.
Oh, let's see. 1, 2, 3, 4, 5, 6, 7, 8. I carried mine out to 9 decimal places.
Oh man. Okay, so I have
What
0.4.
probability? Yeah.
Oh, go ahead. What probability does it kick out? Let me see. What is the question? It's less than? Okay. And I got negative 1.288. So I have 0.0989.
So I have 0.1028.
1028?
Yeah, 0.1028.
Okay, so that's not too far off. Okay, let me go back and see.
Unless it's B.
So it's 0.4266. Let me just carry that out. So, okay, so it's 320 divided by 750 minus 0.45 divided by 0.018165902. 1, 2, 4, 5, 8. Okay, so I essentially got the same thing. I got negative 1.284.
Okay, I was gonna carry out my standard deviation in more decimal places, so.
Okay.
Try that out. 6, 9, Uh, I still got negative 1.26610.833. Is that what you got?
Say it one more time.
I essentially got negative 1.266.
266. No, I got negative 1.284 now. Okay, so when you divide 320 divided by 3 or 750, what probability do you get?
Well, I got 0.427.
Okay, and I just carried out, instead of 427, I did 4266666 minus 0.45.
Okay, I'll try that. Answer minus.
That's so crazy that it makes such a difference.
0.816. Oh, we have a spreadsheet for this.
Oh, we do?
Yeah, let's remember that.
Okay. Okay, so what is the first? I have to find it.
Okay, yeah, so I have that now.
Okay, so then when you type it in, let me know what you get. I think we'll obviously have the same. Categorical data.
So 1.285. So I got 0.0994. What did you get?
I got. Oops, click on the wrong thing. I think I got the same thing. I'll just pull it up. 0.0996. So, oh, and I actually think I typed in one thing wrong. Yeah, 0.0996. That's pretty good, right? 0.099. So that would be enough though, because we're gonna do point. Oh, I would have to round it up. I feel like it's good though. What? Okay, so it's 0.0.
Let me pull up the spreadsheet, and I'll put
Yeah,
in
just trying to put it in the spreadsheet. So 750 and it equals how many? That's 750.
some. Yeah. 750. Null is, I think it's 0.45, right?
Yeah, that's right.
Okay. So I have a p-value. Oh, not. It's less than, right?
Yeah,
So I have 0.009. I just set up to 3 decimal places.
yeah. I had the same. Once I put it in there, I got the same thing. So that's perfect.
Okay. 0.00. Right. 0. Let's see. Suppose you're testing, and you have calculated the test. Z is equal to 1.334. The area to the right of 1.334 is 0.091. Which of the following is the p-value of your hypothesis test?
Isn't it the same thing as the area? 0.0. Oh, no, we have to double it. You want both tails.
Oh yeah. So the 0.091 times 2. So 0.182, right?
Oh, perfect. Yeah, and that's C. We're cruising through this. Halfway. Just over halfway. Okay. Suppose you're a dog breeder and you want a, oh, suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of the fertility level of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal? 5, right? Wait.
I think it's 5.
Are we dealing with proportions, or are we doing
Uh, it seems like it's talking about proportion.
proportions? So proportions, wouldn't it be? I think it would be the NP.
Oh, wait a minute. No, it isn't proportion, is it? Because they're not
Oh yeah, it
using
says
yeah,
mean.
they're,
It
they're
has
using
X. But I think it's 5 because it has X, so it's not proportions, and so then it would be N is greater or equal to 5.
yeah, that's valid. I know for sure, that one's true. I
Perfect.
think the other ones are
Okay,
just yeah, that's cool. Different.
awesome. Okay, so for 26, a study. Oops, let me scroll back. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of the women and men who dislike anchovies are different. A sample of 41 men was taken, and the p-estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was taken, and the p for them was 0.84. Are the requirements satisfied to perform this hypothesis test, and why? I think it has to do with N. It's like the NP thing again.
Oh yeah, for these ones, you have those requirements.
Yeah.
NP. You did for both of them. See if it
Okay.
satisfies
I
both.
think that's what I said. That sounded right. That sounds really right to me too. Okay, I'll do women if you want to do the men.
Okay. That's 41. So for my part, uh, it seems that all conditions are satisfied.
Okay, on my part, the woman didn't have enough.
Oh, okay.
I think it's just the last one. No, the sample woman is too small. Yeah, because 0.16 times 50 was like uh, just under 10.
Mhm.
Okay,
Okay. This database study.
management. Your score, because later they given a score, the study wanted to test whether there was a difference between before and after. What is the correct alternative hypothesis? Um, yeah, I think so too. The difference one. 28. Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. How much weight a client would lose if they followed a prescribed. Okay, volunteers were divided into two groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used a linear regression to present the clients with the exercise program as the explanatory variable and pounds lost in 3 months as the response. Okay, one of the clients was told that his residual was 5.5 pounds. What does this mean? Okay, so from your understanding, without reading it, what does it mean to you?
The residual?
Yeah.
I think it's like the difference in the response variables of like the actual and like the predicted value.
Yeah, I was thinking kind of a difference, like where your data point lies compared to the line that predicts it,
Yeah.
right? Okay. So A, his predicted weight loss was 5.5 higher than his actual weight loss. That's true. His actual weight loss was 5.5 pounds higher than his predicted. I think that his actual weight loss was 5.5 pounds higher if he hadn't exercised. If you didn't exercise, and then it's predicted. I think it's I think it's B.
His actual weight loss was 5.5 higher than his predicted weight loss. And his predicted weight loss was 5.5 higher than his actual loss. Yeah, I think it's probably B as well.
That makes sense. Yeah, the last two I think would be if you compared it with the control group, but they haven't done that yet. So for the study in question 30, the B1 of the regression was 5 pounds. Interpret the statistic. Okay, I always get this confused. B0. What one was B0? What one was B1?
B1 is the slope.
Okay. You need to write that down a few times to get in my head. So B0 is the y-intercept?
Yeah, I believe so.
Okay, so B1 was 5 pounds, so it's 5 over the average weight. Okay, let me go back up because they're saying, I think they're saying for like question 30, but I think they're talking about question 20. So what we've mapped out is the graph where on the bottom is the exercise group, right? Exercise program. And then the y-axis is weight loss.
So for set compliance.
So n equals rise over 1. So 5 pounds for every exercise thing. Okay.
As percent, rise goes up by 1%, on average 5 pounds are lost. I kind of think it would be C, but this is the last part, is if you've lost it.
But the last part,
Sure.
what?
I kind of think it might be C, but I'm not sure.
I think it's C.
Okay. It's kind of the only one that makes sense. So.
Yeah, that's how I feel too. Okay, off.
assumptions about your population of the nations.
Oh, we just did this one. What was the answer? Okay. I think
It's normal. Uh, there is a linear relationship. Variance of the error term is constant, but that's only is those three when we're only checking scatter, residual plot, and QQ plot, right?
okay, so it's not that X are measured without error, and it's not observations are independent because you have to check those separately. Okay. So okay. 31. Pressure. Let me make sure I mark them right. Pressures of supply and demand act directly on the prices of airline ticket. As the seats available begin to fill, the airline. Okay, okay, so we've read the first part of this. Ali Henrik, a BYU student, wanted to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the flight of the same flight. For her study, she compared the prices of one-way flights from London to various destinations in Europe using Travelocity. First, she compared the prices of one-way. Okay. For the lowest published fares for 90-stop midweek flights, 90 days in advance, and then found the lowest published price for the same destination, 14 days in advance. The prices are given in direct flight costs. Notice that for some destination flights were not available. Use this information in 31.
It looks like they want us to compute the correlation.
So just do that instead of the previous test. Do a linear regression one.
I think you go to like analyze and go to correlate. The correlation coefficient.
See if I still have it pulled up. That would be so cool. I don't. Okay. So it's cost. What is the name of the data? Do you remember by chance?
Direct flight cost.
Here we go. Okay. Okay, so we do analyze, correlate. Wait, it's not correlate. Is it regression?
Well, that's if you want to find like the coefficients for like the line, make a regression line. And I think what they want is they want the correlation coefficient.
So how do you do that?
You go to analyze and you go to correlate and then bivariate.
Thank you. Okay, so maybe I didn't put it in there. Let me go back. Do I need to change anything on it? I don't think so.
Let's see. I got 0.780.
Yes, or so I got 0.780. Okay. I need to go over how to read those things. Pretty bad. Create a scatter plot using these two variables. Use the scatter plot referring to the correlation coefficient. Okay. So we can do that. So 90 days is our x, and then 14 days is a y.
I think so.
Okay, I got like there's definitely a positive flow going on,
Yeah.
but
Positive association.
okay, so linear with a fairly strong positive association. Got it.
Missing values in the equation of the linear regression line. This predict price it takes 14 days before flight based on the price it takes less than 9 days before the same flight. Oh, okay. So then analyze regression linear. So our independent is 90 days, right?
Yeah.
Dependent is 14 days. Oh yeah, don't forget to do save. And let's see, predict the
Unstandardized residuals.
Let's see. I'm looking ahead to see if there's something that we need to do. Maybe. They want us to predict the value, and there's a way to do it.
Oh,
You
really?
just have to yeah, in the end. At the end of your list, you just have to input it. So our explanatory variable is 90 days. So at the bottom of that, we put down whatever value we want to predict. So the value we want to predict the price of the tickets, let's see, what can for a flight based on the same flight, costing $290. Oh, 200. 200? That's $200. That is your first flight. Okay. So, analyze regression, linear. So, dependent, save, unstandardized, standardized predicted values. And then, let's see. What constant did you get?
So I got. Sorry, what did I get? What confidence interval, or what was your question?
What constants did you get?
Okay, so I got 0.627 and 0.054. But I never can remember if I'm reading them in the right area. So I was looking under constant, it says 90 days, and then under B for 90 days I got 0.27 and 0.054.
Oh, that's mine. You're looking under the box that says coefficients, right?
Mhm. What did you get?
I got as my Viat. I got 115.640.
I got that. I was just reading right underneath it.
Oh, okay.
Okay, so you read the top one? I'm so sorry, I never remember.
Okay. Yeah, it sounds like we got the same thing.
Okay, so for B, okay, let me go back a minute. So the 115.640 0.40, that's our y-intercept, right?
Yeah.
Okay, then
And for
and
the
then our
slope,
slope is
67.
17.7. Yeah, 17.758.
You got 17.758.
Yeah, what did you get?
Oh, I think 17.758 is your air.
Oh, wait, okay, so where's the slope? Is it right underneath it?
So it's right underneath 115.
Oh,
This is,
darn it. Okay, so that's the 0.627.
I got 0.627.
Yes. Yep, I read.
Oh,
Sorry. Well, yeah, I put a 0 in there, but yeah. Man, sorry, Colby. Thank you for walking me through that. I'm not as comfortable with this last step, so you guys have a good one. Oh. So wait. The y-intercept, so B0, I put 115.67 or 640. Is that what you're putting in?
sorry, what was that?
So for B0, I know it's not. I forgot the name for it. But I did 115.640, right?
Yeah, 115.640.
Okay,
And,
and then for B. Oh, go ahead.
oh, go ahead.
So then for B1, it says just do one decimal point. So you do 0.6.
0.6.
Oh,
Oh,
yeah.
yeah. Yeah, that's right. I was thinking, that's correct.
Okay. It's interesting that it has us only round to one decimal point.
Yeah. And then the predicted value I got was 240.97927. But they only have one decimal place. So it'd be like 241.0
For what one? Sorry.
for 34. Predicted value. They want the one decimal place.
Okay, so you just pretty much put that into the equation.
Kind of. Uh, you I read about online a couple days ago, or it was like, I forgot what it was. But like, in your explanatory variable, uh, you put in a number that you want to be predicted, and then when you actually go to compute like the coefficients,
Uh-huh.
you and you go to predict values and standardize, and so it'll actually make another variable called like prediction one,
Uh-huh.
and uh, the same like row as 200, or as the variable you want to find out like what the value would be, you would find a sort of like estimate.
Oh, okay. So you said how do you do it from, sorry, where do you go in? Analyze?
So under 90 days, the last I guess the last cell in that
Uh,
variable, you type in, I think for this was 200, right?
oh, just at the very bottom.
Yeah, so you write in 200,
Okay.
and then go to analyze regression linear, and then you go to save. And when you're at save, there's predicted values. You see that?
Um,
It's at the top. When you press save, it
oh
pulls
yeah,
up a
yeah.
window.
I thought it was one of the boxes. Yeah, so predictive value, and then you click on standardize.
Yeah.
And do you also have residuals on the standardized click as well?
I didn't click on it. I don't even know if you asked for it again.
Oh, interesting. Okay. But I did it. Okay. And then
Okay, it goes okay, and you did everything else the same. And so when you press OK, uh, it won't show up on that output window, but if you minimize and go back to like where all the data is, it'll have
Oh,
the variable. And then in the same row as the I guess the cost or the price of the ticket that you input in, right next to it should be like a value.
okay. Didn't have anything. So let's try it again. Delete and let's try this one more time. 200 for 90 days. And then analyze linear. Come on. Huh, it didn't come up with the predicted value.
Okay. So you went to regression linear, then you press on save, right?
Uh-huh. And I
Oh,
clicked under the predicted values.
okay, and then you put like an independent variable, you put like 90 days, right?
Uh-huh.
Then you put 14 days, and oh, and predicted values, you press unstandardized, right?
Yeah. Let me unclick residual stuff. Okay, regression,
And
linear.
okay, huh?
Okay, this is weird. Okay, let me see.
Oh, let me show you where it shows up for me.
Okay. Yeah, for oh, I got it. Okay, let me
Okay,
pull up this. Okay, yeah, now I can see it.
so do you have that, or is it not showing up for you?
You know what? Maybe I'm looking at the wrong part. Let me see. Okay. I'll show you what mine looks like too afterwards. Hold on a sec. So, I'll just show you really quickly. Sorry, just 1 second. Try to make it big enough for you to look at.
Oh yeah, oh there isn't anything in there.
Oh
Huh.
yeah, so I must have been scrolling over. So let me show you. Okay, oh, start. Okay, so so this is what I put in here, 200. Then went to analyze, regression, linear, save, predicted, continue. Okay, just minimize that. And then I don't have anything that. Oh,
Yeah,
look at
yeah.
that. I've done. I just didn't know it was over here. Okay, so then this is what keeps popping up here because I've done it like 10 times. So 240979.
Yeah, that's what I got. And
Hey, thank
so
you so much.
I rounded it up to like 241.
2409. So, oh, because that has to be 1 decimal point. Yeah,
Yeah,
I would agree.
1.9.
So 241.0. Okay, give a 95% confidence interval for the slope of regression obtained in the 90-day paper flight. Okay, I think that just shows up in the data we've been picking up, huh?
Should, yeah. Ah,
Huh, 9%.
Oh,
Is it labeled?
confidence interval. You have to go. You have to go and actually enable it for it to show up.
Oh, dang it. Okay. Let's try it again.
Okay, there it is. So
Thank you for showing me where this needs. I'm laughing because I can see that I did that predicting like 5 times. Oh, there it is. So thanks. Okay. So statistics, and we want confidence interval at the 95%, right?
Yeah.
Okay. Okay, so I got 80.332.
Oh, I think that one is for the y-intercept. It's the top one, right?
Yeah, do you need the bottom one?
I think it's because I think they said they give a 95% confidence interval for the slope for the question mark.
Oh.
So I think they want
Okay.
the bottom.
Okay, so I gotta read through this and make sure I can read these right, because that would be awful on the test to get that simple thing wrong. So 0.518
Yeah, that's what they got for the lower bound.
and then 0.735.
Yep.
Okay, choose the correct null and hypothesis for this test. Is it B? That's what I'm
Yeah, I think
thinking.
it is B.
Yeah, that there's just a linear or no linear. Okay, so the test statistic, what do we have here? So do I read the test statistic as 11.509?
I think so.
I think it's the bottom.
And p-value
0.000.
Yeah.
We did that right. We don't have to put in any other.
I think so. Okay, so 38.
Yeah. Let me just make sure.
That's approximately 0, pretty much.
Okay, so decision we make based on the p-value. So we reject the null.
Let's see. So, yeah, reject the null. There
I think
is
it's C.
C. There is sufficient
Yeah,
evidence
there's.
the true linear regression line does not equal 0. On the other one, there is insufficient evidence to suggest that the slope of the true linear regression line does not equal 0. Yeah, I think it's C. That's done.
Okay, and then. Oh. We've done all of these before.
Okay, so for the first one, the United States mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth rate babies born. 30 mothers, all of whom live in poverty, participate in the program, and birth rate data is reported which hypothesis test would be most appropriate for the study. Let's see. So we don't know sigma. So
And it's just one sample, right?
yeah, I don't think it's gonna be proportion. So you can pretty much knock out the number letter F and below, right?
Yeah.
So it's like
So
C,
is it
E, or E, I think.
C or E?
So let's
What did
see.
you?
Are we comparing? Let's see. What groups are we comparing?
So it says in those mothers who live in poverty generally have babies with lower birth weights. The mean birth weight is this. The CDC carries out a study to test the effectiveness of a prenatal. So they're seeing we're trying to see how effective a prenatal care program is.
Uh-huh.
For the study, they take 30 mothers, they put them in this program, and then they test the birth rate reported.
Mm-hmm.
So you're just taking a sample mean and comparing it with the population mean. But we don't know sigma. So would it be B?
Oh, do we have a B? Oh, yeah, we do. Yeah, I think it would be.
Okay, so how do you scroll down there? Okay, engineers in an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation, the vapor pressure of gasoline made by the refinery is always this. Which hypothesis would be most appropriate for the task?
Vapor pressure. So it's definitely not going to be, again, anything below F, at least. Probably going to be like a number A, or I guess letter A.
But does it have the standard deviation? Oh, it does have the same.
Yeah.
Even though there's no mean?
I don't know. Hmm.
Have we ever done that? I don't think we've ever done this one before, already.
Yeah,
No.
but I forgot. Well, I don't know, like we have as a group, but I know like I've heard this question.
Yeah, we've confronted this before. Okay,
One sample is probably the most appropriate because, like, we know sigma, and the others we assume don't know sigma, right?
yeah, that makes sense. I'm gonna see if I can go back. I wish I had a summary of all the pages for that. Let me go back and see if I can find any. Like the flow chart, you know?
Mm-hmm.
I can't remember. So, Okay, I think it is. So I just looked up summary for the z-test. So if sigma is known and there's a large sample, then you can do the z-test.
Mm-hmm.
So I think that's good. If we don't know, if we don't know the sigma, then we do a t-test. So I think we need to do, I think it's A.
41. Attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation?
So it's proportions, and it's just, you have mu. So is it just one test, one sample proportion testing?
That's what I kind of think it is.
That makes sense. I can't see it really being anything else. We don't have enough information.
Yeah, there's not like two different things we're comparing, so.
Yeah. Makes sense. Okay, a marriage counselor conducted a study of couples, categorizing each of the couples as communicative and non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriages ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in divorce or separation. Is it a test of two proportions?
Yeah, I think it is.
Okay, because it is proportions, right?
Yeah, we're not really like measuring things. We're only like counting number of observations. So yeah.
Oh, that makes sense. Yeah, just like it's not quantitative so much as qualitative. Okay, a business marketing firm specializes in radio advertising. They hope to show that there's a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedures the list above would be the most appropriate? Linear regression?
Yeah,
Okay, so just to make sure I put in these letters right, so for 39 I have B, then A, then F, then G, then I.
Yep, so I have to.
Okay, awesome. Oh, are we so ready to turn this in?
I think that's been like the longest one.
That was like a whole exam, I felt like. Right. But it did make me feel good. I felt like we caught a lot of the little things. Okay, let's see how we did here.
Oh
my god.
But you can actually retake.
Oh, you can?
Yeah, those can.
I'm scared to touch that though. Like, do we will give us new answers for 42 questions?
Probably. I'll just take it. I don't do any more of this.
Yeah, no, I'm so done. But I did notice number 4 again. It got us. Got that wrong last time too.
And it said number 13 was wrong as well.
Yeah. Darn it, after all our double checking. I wonder how that happened. Could have been like a decimal, or it could have been really substantial. We don't know. Number 25 too, huh? Maybe it was n greater than 30, I don't know.
Yeah. Maybe greater than 5 is only for proportions. Maybe.
Yeah, maybe that's it. I'd have to go back and check. That kind of rings a bell. Well, overall though, I feel like we did pretty good. I'll have to go back and study those ones. I'm nervous about, I want to see what the retake's about, but I don't really want to redo it all.
Well, it said we got wrong as well.
What?
It says we got number 36 wrong as well.
Is that the... Oh, yeah. I was so confident. Did we mess up the mean and the... Because we also got number 33 wrong. Let me look. Like, did we just switch?
They were supposed to do the other way around. Of course, then we got 34
Yeah.
right.
Hmm.
Maybe it's just like the way, like, for some of these, it could just be the way you enter it. It just doesn't work.
Yeah. Okay, but here it says that B1 is the slope, and B0 is the y-intercept, right?
Yeah.
Yeah, that's weird. Man, we'll have to check with that. Go back to calculator. Oh man, I just closed my whole internet, darn it. This quiz, it's due tonight though, right?
Yeah.
Okay. Because I'd be interested in going back and redoing a few of those, but I'm so, like, that took so long. I do not want to do it tonight.
Yeah.
So, maybe not. Luckily, we still did pretty well.
Yeah.
Okay, cool. Well, any other questions? So, okay, so there is that PowerPoint due on Saturday and the take action.
Mm-hmm.
And then I'll call Brant, I guess. And then also the exam, right?
Yeah.
But the exam next week, you're saying.
Yeah. Do we want to have Brent take action just because he's probably going to be busy?
That's true. Yeah, we could do that, and then we could just work on the PowerPoint.
Okay.
Okay, so today is Thursday. When do you want to meet to look at that?
Let's see. 183.
I can do tomorrow. I can do tomorrow at like 9:30ish. So like 7 or like 7 o'clock your time and on. So same time as today. Or I can do Saturday. I'm gonna go out with the missionaries. But I could do 7 o'clock my time, so 4 o'clock your time and on, or 5 o'clock your time and on.
5 o'clock. You said 5 o'clock on Saturday?
Yeah. Or later. Whatever works better for you. They asked me to go to 2 lessons, so I don't know like how long it'll last, but if I need to be home at 5 o'clock your time, I can.
Okay. Yeah, whichever day is, better for you.
Well, okay, so looking at what we have to do, because maybe tomorrow like we can work on a little bit of it, and then we can combine it on Saturday.
Okay. So.
I'm just trying to pull it up.
You said Friday at 7 o'clock my time?
Yeah. So like the same time as our lessons.
Oh, okay, yeah.
Okay, so I just pulled up the rubric for the PowerPoint, and I just says, okay, a brief but clear, so you have to have a slide on design the study. A brief but clear explanation of the project includes information such as the research question, the population, the sample size. Data. So essentially, we just take every single thing we've done, but we do a simple explanation of each part of the text.
Mm-hmm.
So do you want to just kind of, maybe we could work on it separately tomorrow and then combine it
Okay.
on Saturday?
Yeah, we can do that.
Okay. I can do the describe the data because that's what I did as well. And I really don't care whether it's design the study. I hate graphs, so maybe not data collection, but design the study or make inference or any of those.
Well, they just I can do like design the study.
Uh-huh.
And you can do like describe data, since you did that one. Probably easier for you.
Okay. Yeah, and I can do make imprints because I helped Brand with a lot of it. Well, I mean, he did the work, but we went over all those answers. If you want to do the first two, and I'll do the last two, and then we can just combine on the last one.
Yeah.
Okay, that sounds good. Okay, then I'll just start on that tomorrow, and I'll just focus on getting the information on the slides, and then we can make them the same color and stuff when we combine it.
Yeah. Oh yeah, can you send
Okay,
me
cool.
the data that you got? I
Yeah.
guess maybe.
Yeah, I think I put them all in one Excel sheet. So let me just send that to you really quick. I think it has a graph on there as well, but everything you need. Let's see. Colby, what's your email address?
It's youthwalk@gmail.com.
Sorry, say it one more time. Colby Walk. ColbyWalk@gmail.com. Okay. Okay, research data is there. Okay, you should get it in a second, and I'm just gonna pull it up and make sure it has everything on there.
Good.
So yeah, that should work for you. I think just fine. Yeah, I try to just like color coordinate them as far as like the first 10 bags and 11 to 21 bags and stuff. So